In question 8 we have a function and we want to know where the function is increasing. So in question 8 we have the following function: f of x equals to ln of x divided by x, and we also know that x has to be positive. Why does x have to be positive? Because look, we have here ln of x, and remember this rule that whenever we have a logarithm, the input has to be positive. We cannot have logarithm of a negative number. That's why this is a criteria for our domain. Now, what does it mean to have a range where the function is increasing? So basically, what does it mean that f of x is increasing, f of x is going up? Well, let's see it on a graph, because if we look at it on a graph, it will all make more sense. So if we have a graph, and let's say the graph would look something like that. We have the xy axis, and our graph would look something like this. So it would be curvy, so it would go like that. Well, where is the function increasing? The function is increasing when y takes higher and higher values. For instance, the function is going up on this range over here. So we can see that as x increases, x goes to the right, the y values get higher and higher. For this x value, we have this following y value. For this x value, we have a higher y value. We have a higher y value, and so on. So what did we just show here? We just showed that the function is increasing when the change in y relative to the change in x is positive, meaning that our delta y over delta x has to be positive. What is our delta y over delta x? That's our derivative. That's the tangent slope to the curve. The derivative at this point, it has to be positive for the function to be increasing. So if that holds true, then we know that f of x is increasing on this range. And the opposite happens. If we look on this range over here, let's go from y at this point up to this value over here. Well, we can see that as x increases further, our y value goes down. So if x was at this point over here, when x increases up to this value over here, our y value goes down. So delta y over delta x becomes negative in that case. So the slope of the tangent line is negative. And visually it makes sense, because indeed we have a downward sloping line. So this is sloping downwards, it goes down, so that's why it has a negative sign. But this slope over here goes up, that's why it has a positive sign. So the derivative has to be positive for the function to increase. Well, what can we do now? We can find out our derivative. That's the most natural thing to do. So f prime of x would be equal to the derivative of ln of x divided by x. Now what do we have here? We have the quotient rule. We have a division of two functions. So we would have the derivative of ln x times x minus ln x times x derivative divided by x to the power of 2. Okay, well that's equal to, what's ln x derivative? That is 1 over x. So we have 1 over x times x minus ln of x times x derivative, which is just 1, divided by x squared. Okay, what do we do now? X and x cancels out, so x and x cancels out, and we're left with 1 minus ln of x divided by x squared. Okay, 1 minus ln of x divided by x squared has to be positive for the function to increase. So 1 minus ln of x divided by x squared must be positive. Now x squared is always positive. Any number to the power of 2 is going to be positive, which means that the only thing that we're left with is 1 minus ln of x has to be positive, which means that 1 must be greater than or equal to ln x. Okay, ln x, let's write it as ln x has to be less than or equal to 1. Now, if ln x has to be less than or equal to 1, and we know that ln of e is equal to 1, ln of e is equal to 1, Well, that means that x has to have values less than e. So if ln of e will take the value of 1 and ln of x can be at most 1, so ln of x can be at most 1 when x would equal to e. And if we want values less than 1, well, that would mean that x has to be less than e, less than or equal to e. And also remember from our domain that x has to have value greater than 0. Remember, that was part in our domain over here. X has to be greater than 0. X has to be greater than 0. So x has to be greater than 0 and less than or equal to 1. That would be our final answer. And if we write it a bit differently, just a bit more mathematically, so to speak, that would look something like that, from 0 until e included. And that's it, we're done.